I already had a lovely introduction. 1,5 for the people who don't know it. Can I? Yeah, does that work? We do all sorts of energy stuff, and they're like a one-stop shop for energy things. Today's short agenda. First, I want to tell you why security in climate tech, specifically machine learning, matters. Then I'll break down some machine learning security risks, some real-world attacks that actually happened, and then I'll tell you more about how to protect models in your whole life cycle. First, why climate tech? Why do we do this at all? The main reason currently is that we have a 4% expected annual increase in electricity consumption throughout the next years, mainly driven by a growing use in the industry. We need air conditioning because our planet is getting more and more hot. We have more electrification, we have electric vehicles, and we have really hungry LLMs that need huge data centers that also need a lot of energy. But we also have more and more solar panels and also more smart home energy management systems. I'll come to them in a little bit. And they can also significantly help reduce CO2 emissions. So the TU Berlin, TU Munich, and other research institutes did simulations to see what would happen if most of the rooftops that we have, or just 0.1% of the landmass, would be covered with photovoltaics. And that would not only reduce CO2 emissions, it would actually reduce the temperature of the planet by 2050. So something we could strive for to actually have a little bit more. What are real-world examples of climate tech? The first one is called eGridGPT. It's a Gen AI model to assist control room operators. It's one prominent example from the US National Renewable Energy Laboratory. And this model supports the control room operators with decision-making, interprets and enables the data that it sees. And the main goal is to enhance the grid stability by kind of like supporting proactive decisions that can be taken that are a lot harder for without AI to see. And Gartner did a research that by 2027, 40% of all control rooms will be somehow driven AI related. And the next one is something that also my company does, is home energy management systems. So these are systems that connect your solar panels, your batteries, your EVs, your heat pumps, and then optimizes the energy flows around the house. So you can then optimize to kind of like have your self-sufficiency, so you need as little as possible from the grid, but you can also optimize to have the cheapest kind of like energy. So most of you probably have a static tariff, but you can also have a fluctuating tariff, because the energy market kind of like trades energy depending on supply and demand. So at night, for example, when most of us are asleep and the demand is a lot lower, supply can be high, for example, towards wind, energy can be a lot cheaper, and if you have a dynamic tariff, then you can have cheaper energy, for example, by charging your car at night. I'll take this off. 1 second. Can I take this off? 1 second. Help. Okay. Better. Thank you. However, so this is in your house, but you cannot be expected to have the same level of security as large power plants, for example. So this is why we need security in climate tech. We established increased demand for electricity. Means we also need more efficient production and consumption, and AI can help with us. But we also have escalated cyber threats, and we have new vulnerabilities at the heart of our energy infrastructure. Specifically, if you have more and more connected devices and more connected homes, the more you connect stuff, the more you can also influence the grid on a larger and larger scale. I brought you the Forescout report, and it highlighted the alarming trend in the last 3 years that 80% of the new vulnerabilities they found had a high or critical severity, and 32% had a 9.8 or 10 CVSS score, which means the attacker can take full control of your system. And this is your house, right? Like, in your house, someone can fully go in and take control over everything. What is most at risk? So solar monitors and cloud backends, which is something that a lot of us probably also work on. And if you have access to these, specifically if you have access, like full control over it, and full control over a lot of systems in close proximity, you can destabilize the grid, but you can also get access to a lot of really, really sensitive data. So, machine learning security risks. You might know OWASP. They have security top 10s, but they also have machine learning security top 10s. They're an open worldwide application security project, a non-profit foundation. And this is the full list of 10 things. I will not present all 10 today. I will focus on 3: the input manipulation attack, the data poisoning attack, and AI supply chain attack. First, input manipulation attack. So you have carefully crafted inputs to kind of like trick the model to make wrong decisions and misclassify. So for example, in our example, we said, okay, prices can vary throughout the day. And you can say, okay, if you get access to the system, you can also say, maybe the price is now something else. I want you to behave differently. And then if you say that to a lot of homes, maybe they think it's a good time to discharge their battery all at once. Which would then, depending on kind of like your emergency infrastructure, you could destabilize the grid, but you could also have a lot of loss on the customer side and the company side. And especially for coordinated attacks, this can be quite dangerous. And something that I learned from you, actually, is this toaster, where you have this lovely sticker, and if you want, as an example, to put it next to a banana, it will then classify it as a toaster instead of a banana. And I thought it was a very good example, so I stole that. Thank you very much. Then data poisoning. So in the first one, we had a kind of fine working model and said, okay, but we manipulate you in the kind of like running infrastructure with some examples. Here, we actually want to manipulate during the training process. So we're injecting, or attackers, injecting false or misleading data during the training to lead the model to learn wrong patterns. And you can have malicious actors, but obviously you can also kind of like poison data if it's not so good anymore. So if you get access to the system and then continuously kind of like change the sensor data, then it's not super useful for the training anymore. So what could happen? Models often estimate load to kind of like see how much energy should be bought on the energy market. And if you have poison training data, it could lead to overestimating the load that you need to buy, and you buy unnecessarily large amounts of energy. The next attack is summarized by this picture. Most of you have probably seen this. It's a random person in Nebraska that maintains a library, thanklessly, and kind of like all of your machine learning models are probably built upon it. What I'm talking about is a supply chain attack. So how a hack library from this like one Nebraska person, which probably doesn't have too much time, could actually lead to a widespread kind of like exploit. So a lot of machine learning models do rely on open source, and a lot of us also rely on open source. But attackers can also tamper with third-party libraries and pre-trained models. So poison packages could lead to wrong predictions, could lead to data breaches. You could have models that have backdoors, that gain access to your system, or manipulate outputs. And then again, wrong predictions on the energy demands, you can have all kinds of outcomes here. But now towards kind of like real world attacks. The first one I want to show you is how to hijack an inverter. This is also from the ForeScout report, which was an actual vulnerability they found in one of the inverters. So an inverter, if you don't know, it's a power inverter that converts DC into AC current, and which means that, or kind of like your PV produces one current and then you transfer it so you can use it in your house. So an attacker could guess usernames through like an exposed API, for example, or obtain them otherwise, and then by exploiting some vulnerabilities, the attacker can reset the password. In one example, the resetted password was then 1, 2, 3, 4, 5, 6. Or they could inject some JavaScript and steal some credentials. That also worked. Once you have access to the accounts, full access, then by the way, because you have all of everything you need to log in, you can tamper with their power output settings, which would switch them on and off. And because these vulnerabilities are on the provider level, so these are usually built in several homes, then you can also do this in a coordinated way if you know where they are. And depending on the grid emergency capacity, also you can see how much damage you could do. The next one, also a real one, is called Poison GPT. It was done by the Mithril security researchers, so not actually bad actors, but nice people wanting to highlight this. What happens if you manipulate a pre-trained LLM and then kind of like say, I want you to generate false or misleading information. And then I re-upload this to Hugging Face and see what happens. And nothing happened. It was not detected, it was not deleted, nothing was done. So anyone can use it, anyone can kind of like play with this. And this is also, I mean, this was made publicly by researchers, but other people might be able to do this too. And the next attack was a compromised PyTorch dependency. So malicious malware was submitted to the Python package index and compromised the Linux package PyTorch Nightly, which is the pre-release version of PyTorch on Linux. And it used something called dependency confusion, where you install a fake package, which has the same name as the real kind of like dependency. And that worked. And then kind of like PyTorch Nightly was like, I'll take this package instead. Seems fairly the same. Wasn't. And it was live for 5 days until PyTorch disclosed the issue and actually removed the dependency and urged users to uninstall it because you can't get it out of the version. So, how to protect your models? First, before you train, validate and clean your data. So I think that's common good practice in general. Filter out the noise, outliers, implausible values. If a heat pump says it's running for 24/7, it's probably not the case, so you might want to look into it. Then least privilege access. Give access only to people who really need it. Configure role-based access controls, which also helps with this. And then containerize with care. Only package machine learning models with the minimal dependencies you need. The smaller it is, the safer and easier to audit. After you train, also monitor for anomalies. Also, I think just these are good practices, I think, in general. If you have sudden spikes in load forecasts, maybe it's an exploit, maybe not, maybe it's fine. But also update your models regularly. It's annoying to have model drift, but it's also a security risk. Then perform adversarial or red team, if you know this, testing of your models. So actually have internal teams or external teams test your models. So identify where your model is the most vulnerable. So we had, in this case, malicious inputs. We had poison training data. we could have a hack library. Can you identify any of those? But you also had the other list of like 10 things. So go through them, see if you can play around with your model, see if you can trick it, and then also see how you can build it in a more robust way. Have more edge cases, for example, in your training data set. Build stuff in that you've seen, say how it should respond. Just generally make sure your model can be a bit more robust. And AI can also contribute to a stronger cybersecurity. It is also a risk, but we can't have our eyes everywhere. And sometimes for anomalies, for example, it's better to have an AI look at it than to have like a very basic monitor that can only scan for certain things. So, key takeaways. Secure machine learning models, it's not optional. Then security should be by design. You should build it in. Don't kind of like bolt it on in the end somehow. Also have machine learning specific risk assessments. Go beyond the generic audits, analyze and test your data flows, your model behavior, see where you can have attack surfaces. And really important, also kind of like skill your teams across. So have your machine learning teams kind of like look into security threats, but also train your security teams. What are you doing with machine learning? And then not just train people, also work together and collaborate, because together we're all a little bit smarter. That was it. Thank you very much. I have a podcast. It's called Unmuted. We talk about all things in tech. If you're interested, you can follow us. And you can also follow me on LinkedIn if you want. And thank you very much. Do you have any questions?
Yeah, we have. Okay, so we have 2 questions at the Slido at the moment. So you guys can register your questions right now because we have some time left. So I'll read out some questions to address. So how do energy companies can identify potential cyber threats or vulnerabilities?
So energy companies specifically. So I think the largest or the biggest thing is to actually have people look into it. So for example, we have a security team that tests it and then also goes around to see kind of like where they can poke holes into other teams' systems. But also then, so we work quite closely with them and then also say, okay, they say, look into this, you should be careful of that. And then everybody kind of like has an eye on it. So I think it's a culture thing to everybody actually say, okay, this is something we need, this is important, but then also have specifically people going around and say like, what can I break?
The risks seem not only AI related, right? If the smart home control system without AI is hacked, we have the same risk.
Yeah, it's true. Like you don't, like it can be a security risk from AI, but it can also be a security risk without AI. However, the home energy management system without AI, so it works without AI, but it makes it more useful to have AI in the system in general.
How do you keep updated and informed on vulnerabilities and security incidents?
I have a lot of newsletters, and I try to read them. Sometimes it works and sometimes it doesn't, but I kind of like it to just scan it.
I think that's it. So we want to thank you, Doreen. So that was a wonderful talk. So please give her a round of applause.